Let us see a very good question, but very simple, of CSIR Group C, December 2015. Consider non-zero vector spaces v1, v2, v3, v4 and the linear transformation phi1 from this phi2 and phi3 such that kernel phi1 is equal to a singleton 0, range phi1 equal to kernel phi2, range phi2 equal to kernel phi3 and range phi3 is equal to dimension of this vector space v4. Okay, then choose the correct option. So it is a simple question. First I suggest you pause the video and try by yourself, okay, since it is very simple. Let us see how we solve it. There be given the kernel of phi1 is equal to 0. Okay, this means to what? It means kernel null space of phi1 has only singleton 0, therefore its dimension is what? Dimension is 0. Okay, and dimension of kernel phi1 is equal to simply 0. Okay, this implies nullity of phi1 is equal to 0, and by rank nullity theorem, rank plus nullity theorem, okay, what? Rank of phi1 plus nullity of phi1 is equal to dimension of v1. Okay, because phi1 from v1 to v2. Okay, now nullity of phi1 is equal to 0, so this implies rank of phi1 is equal to what? It is simply dimension of v1. Okay, now move to next, phi2 from v2 to v3. Okay, and for phi2 range of phi1 is equal to kernel of phi2. Okay, it means what? It means dimension of range of phi1 is equal to dimension of kernel of phi2. So we may write this implies rank of phi1, this rank of phi1 is equal to what? Is equal to nullity of phi2, nullity of phi2. Okay, so we again apply the rank nullity theorem for phi2. Okay, so rank of phi2 plus nullity of phi2 is equal to dimension of domain v2. Okay, now rank of nullity of phi2 is equal to rank of phi1. Okay, so rank of phi2 plus this is replaced by rank of phi1 is equal to dimension of v2 using using this relation. Okay, so this implies simply rank of phi2 is equal to what? Is equal to dimension of v2 minus rank of phi1, and rank of phi1 is what? It is dimension of v1, dimension of v1. Okay, now move for phi3. So for phi3 again rank of phi3 plus nullity of phi3 is equal to dimension of v3, dimension of domain. Okay, now using the another relation, range phi2 is equal to kernel phi3, that means dimension of range phi2 is equal to dimension of kernel phi3. So this implies rank of phi2 is equal to nullity of phi3. Okay, so for phi3 we can replace nullity of phi3 by rank of phi2, so it is rank of phi2. Okay, and it is rank of phi3 is equal to, it is dimension of v3. So by this relation, rank of this phi3 is equal to what? It is dimension of v3 minus rank of phi2. Okay, and rank of phi2 is what? Rank of phi2 is this one. So this implies rank of phi3 is equal to dimension of v3 minus rank of phi 2, dimension of v2, so minus dimension of v2 and plus dimension of v1. Clear? Now for the last one, phi 4, rank of phi 4, okay, plus nullity of phi 4 is equal to dimension of only phi 3 is given, so we not have given the transformation phi 4. Okay, so only it is given that the range of phi 3, okay, given what is given, fourth one is, yes, range of phi 3 is equal to dimension of v4. That means dimension of what is the given, range of phi 3 is equal to dimension v4. Okay, it means dimension of range range of phi 3, actually this one here, range of dimension of range of phi 3 is equal to dimension of v4. Okay, here actually dimension, because it is equal to dimension, not the space, so it is dimension of range phi 3 is equal to dimension of v4. So this implies rank phi 3 is equal to what? It is equal to simply dimension v4. Okay, so the dimension v4 is rank phi 3 is dimension v4. So this rank phi 3 is actually dimension v4. So this one is equal to dimension v3 minus dimension v2 plus dimension v1. Okay, when we arrange it, we get dimension of minus of dimension of v1 plus of dimension of v2 minus of dimension of v3 and plus of dimension of v4 is equal to 0. That is alternate sum of this dimension is 0. So we can write in summation I1 to 4 minus 1 to the power iota I, simply dimension of vi is equal to 0. Okay, so the correct option is A. Option A is correct. Okay, look at the option B. For the option B, we have to find I from 2 to 4 minus 1 I dimension vi. Okay, it is actually when we put I2, we get dimension of simply v2. When put I equal to 3 minus of dimension v3 and put I equal to 4 plus of dimension v4, then this one is equal to, if you see from this relation, then this term dimension of v2 minus this is equal to simply dimension of v1. And since given all the vector spaces are non-zero, okay, given here the vector spaces v1 v2 v3 v4 are non-zero. Non-zero means there be some another element of some another non-zero element in v1. It means the dimension of v1 is positive. Okay, so it is positive, so the correct option B is also correct. This one is also correct option. Now option C and option D, since it is like the option 1 and option 1 hold this correct relation, so C and D is wrong. Okay, so only 2 is correct, A and B. So the correct option here is only A and B. Okay, so guys, it is a simple question. If you deal positively, okay, then very easily you can do it. Okay, thank you very much.